Okay, so the last thing we did as we were working on our well tie was to examine the frequency content in our area of interest, and then extract a wavelet based on that frequency content. And the wavelet uh, will result in a filter that's very similar to what is found inside the seismic data. Fairly straightforward process. And so what we're looking at now is our um, seismic data in this area with a bunch of coal beds. And then we have our well synthetic dropped right in the middle. And we've aligned the formation tops with known geological points on our seismic data. And we've regenerated the seismic based on the wavelet. I'm going to hide this frequency content window here. Just simply click on that. And I'm also not going to show this red. That's our range that we use for frequency content. Again, view, show frequency content range. Nope, take that off. I'm still seeing it's difficult to see because we're looking at the wiggles in black. I've got a black dashed outline. That's defining the range of time where we're doing the correlation between calculations between the seismic trace to the left and the synthetic trace, and its value is currently shown down there as a 0.04. So what we're looking at here is not a really great tie. Now, let's make sure we understand what we're looking at. On the seismic data, in this case, we're looking at some near offsets, and our synthetic data is a near offset. It's a 1D trace. So, but we're also looking at a conventional uh, primary on our synthetic. Okay, this is a constant wavelet put in there. Now, one of the things that we can do very easily in TIPS is we can create well log synthetics with and without multiples. And well, I'm going to tell you that in this data, this seismic data, where we have all these coal beds, we do have a lot of, at least the potential for internal multiples. And there are ways to examine that with the 1D synthetic modeling portion of TIPS, which can be found in another video. But for right now, it's doing a well tie. Let's see if examining a synthetic with internal multiples would give us a little better match to the seismic data. So, one of the ways that we can think about doing this is, well, we could go to our seismic data and try to remove all the multiples, which is a time-consuming, difficult process. Or we can just put the multiples with time-varying wavelets into the seismic data and see if there's a tie, see if that matches with our seismic data. So you might think, okay, we've got to go back to the main menu, go to the 1D synthetics, put the multiples on, come back. No, we don't have to do all that. If we look at our well uh, toolbar across here, we have a drop down over here called conventional primaries. And it's also shown here that this is coal bed example well, conventional primary. I can hit the drop down, and the other option we have is a generalized primary, which is has a time varying wavelet plus primaries plus multiples. And when I click on that, the synthetic changes, and we can see the text right here shown. So before we examine the actual curves, let's go back. Conventional primary. Okay, this is no internal multiples. And then I click it again, and now we have it with multiples. I'm going to bump up the trace gain of the well just so that we can see. And I'll bump down the trace gain of the seismic. So um, again, we're trying to get a good visual here. Well, one of the things we see when we go to the multiples, we've got a nice event spacing that seems to correlate a little bit better. And we've noticed that our correlation coefficient jumped up to 0.476. So again, I'm going to go back to the conventional primary, and our cross correlation was 0.047. And now when I'm looking at the multiples, it's 0.476. So it's much, much better. Um, Now we could look at this and we could say, all right, maybe we should just stretch and squeeze to get this to line up. We could try that. We don't want to shift it up and down because we know that formation top ties nicely. One of the things we can examine is what about a different phase angle um, on the synthetic. So the way we do that is we can come to our wavelet toolbar here, which is telling us that we're using this coal bed example extracted wavelet. I'm at 1 milliseconds and I'm at 0 degrees phase shift on it. Um, we can click on the seismic controls button there that would take us into that wavelet, and we could change it there. Or when we're doing the well tie, we can incrementally change the phase angle. It'll change it by 10 degrees every time we click on it. Here's the current phase at 0 degrees. And we're going to focus on our correlation coefficient of 0.476. And if I click on this, notice we're now at a 10 degrees phase, and I'm at 0.367. I'm going to go back to where it was, 47637. Okay, so it's a little bit worse, and I'm going to keep incrementing through. So now I'm up to 70 degrees, and I see my correlation is at 387. And now getting up and getting a much better coefficient. And if we watch the synthetic, we'll notice that it's starting to match much, much better with the seismic data. But I'm at a 0.584, which let's change that again. Now I'm at 657. So it's between watching this, let's focus on the synthetic, and we go a little bit better. And so our eye is telling us one thing, and the data is also supporting that information. We notice that we get up to 140 degrees, our correlation coefficient actually started going down a bit. So I'm going to go back to 130 degrees, and I'm at 753. And that's about our highest that we're going to get through an increment. I could open this up and change this to 128 and check it that way, the finer increment, or we can just accept it as is. So now we look and we have a really, really nice well tie at the formations. We've got a nice match and a good correlation coefficient. And I think at this point we could say that the well synthetic ties well with the seismic data. The one last tool that we could apply to this is a stretch and squeeze, but we'll save that for another video. So what does this tell us right now? And I'm going to change the view just a bit. I'm going to turn off this rat range, and then for the sake of display, I'm going to go to a color plot, turn the wiggles off. Okay, and so we can see our cold top, and we can see this nice tie. We know that ties nicely, and that gives us a good picture that we can present. So what have we learned on this? First of all, to do the well tie, let's try using a wavelet sourced from the seismic data. Let's adjust the phase as needed. Examine whether multiples are a contributing factor or not. A lot of times they may not be, but you can easily test it by going back and forth. So in this particular example, we're very confident now that our seismic data contains internal multiples, and in order to get a nice tie, the seismic's got a 130 degree phase shift. One of the things we could do is reprocess the seismic data to take that phase shift out of it, and B, try to identify and suppress the internal multiples. But very quickly and easily, and using the TIPS well log modeler, we've been able to perform a well tie, quantify it with calculations, and then able to produce the output. And one last thing, if we want to take the output, we wanted to output this synthetic trace to SegY or ASCII, we could do that. And also we could output the wavelet that we just extracted to a SegY or an ASCII format. So that's a great overview of an initial well tie process, and we'll have some more examples getting into things like stretch and squeeze and popping in the AVO stack in our well tie. Thanks for watching.